Hello everyone, I am Dr.M.Manickam, Assistant Professor, Department of Physics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So today in this video we are going to discuss and explain about sum of an array, that is ALP program of sum of an array. So ALP means assembly language program. Particularly in Microprocessor 8086 we are using sum of an array. So we'll explain in detail about the sum of an array. So this is the lecture series video. Continuously we are talking about the microprocessor 8086 and assembly language programs in 8086. So today this is the video for a sum of an array. So let's explain sum of an array. This is a source program for sum of an array. See here. So move first step of source program in microprocessor 8086 is move SI comma 1100. So which means set SI register as pointer for array. So this SI register is a pointer one. So second step, move DI comma 1200. Here DI register as pointer for result. So this is for SI register for array. Then 1200 DI is for a pointer. So next step, move CL comma SI. So here which means already SI register is assigned for array. So that array is moved to data are moved to the CL register. So that is the CL. We are using CL as a count here. So next step, INC SI, set SI to point to first byte of array. So we are increasing, for example, we are taking 6 numbers or 7 numbers in an array means. So continuously first step it is taking first number. So next we have to increase one count. So then only it will take another output, another input as fetching for program purpose. So we are using INC, that is increment command we are using to increase the SI register value or count. So next step, move AX comma 0000. So set initial sum as 0 here. So this is the AX register. It is a 16-bit register. So we are reset that or take it is a 0 as number in AX register initially. Next step, add AL comma SI. Here add a bit of a byte of array to sum. So we are adding SI means for first data we are taking means first data will add with already existing data of AL. So we are adding both the values. So next step, after the addition, the JNC ahead means it will go to the INC SI registers. So here JNC means jump on no carry. So if you are adding AL and SI register, if you are getting any carry means it will go to INC next step, that is INC AH. Otherwise it will jump to INC SI. So this is what we are using JNC command or instruction here. So next step, after the if the value addition value is getting a carry means it will jump to INC SI. It will increment the array of pointer. So again next step, that is loop again. So again means that step that is add AL comma SI step. It will loop after if you are taking 6 value or 7 values means when it will come to end, after that only it will move to the next step. Otherwise loop program will going continuously repeating up to the end of the value. So next step, move DI comma AX. So finally AX got the value sum of an array, all the data added, and the finally it will stored in AX register. That AX register is moved to the DI pointer. So DI, it will pointer to the 1200 address. So directly the address or the data, final output data, will store in the 1200. So HLD is the end of the program. So we are using to end the program. So here is the algorithm for the particular sum of an array. So in sum of an array, simply you can say it is, you can take 4 value, 3 value, 7 value, 8 value, 9 value, whatever it may be. So in an array, the number of values we can take, or numbers we can take. So first, initially you have to give the count. So if you are taking in 8 values, means you have to give 8 as a count. Then again you have to give the inputs after the feeding the source program. We have to give the input separately. Then it will function or run the program. Finally, it will execute and give the outputs here. So algorithm for first step, that is load the address of the array in SA register, and again second step, load the address of result in DA register. Then load the count value in CL register. Then next step, let's the content of the AX be sum, and keep initial sum as 0. So we are reset the AX register here. So add the byte of array to sum. So in a fifth step, that is AL register have some value, and SA register pointer have some value, first value or second value, whatever it may be. So we are adding. So after it will keep aside the AX register, AL register has the same value, and second step, it will go to the loop by using the looping concept. Second value will move, and second value also will add with the previous answer. Continuously it is repeating again up to the final value get. Okay. So next step, that increment the high byte of some value in AX register, increment the array pointer next step, and then finally decrement the counter CL register. Then if the count is 0, so jumping command we are using here. If the count is 0, means it will jump to the some step. Otherwise it will skip the or increment. If the condition is yes, means it will jump to some other line. Otherwise it will run the next sequence. Then finally the output, store the output value in 1200 address, and then last step, that is stop or end of the program. So this is the steps we are following to from the input giving to the execution, up to execution. So this is a flowchart for the particular sum of an array assembly language program. First step, that is start. Then as I said in the algorithm, so it follows these flowcharts. Load the first data in a SA register. So sorry, first data that is load the address of array in SA register first. Then result address stored in the DA register. So load the count value of CL register, and next step, initially the sum AX as 0. Add the next step, add byte of array to sum. So next step, that is JNC command. So this is the important one in the program. So so this is the jump command, JNC, jump on no carry. So if the value is, if adding two numbers, means if the value is has carry, means the condition is yes, means it will go to some value, some line. So no means it will go to some other line. So this is the actual jumping command usage. So so CF, here we are using a different concept of JC and JNC here. CF is equal to 1, means if it is yes, means it will increment high byte some value, that is AH register, then move to increment address pointer. So otherwise, if it is condition is no, means it will directly go to the increment address pointer. So it will skip the increment of high byte some other, that is AX register. So next step, it will move to the decremental the counter, the count, and so next step, that is a looping concept. So if the CL is equal to 0 means, if it is yes means store the some value, I mean answer will store in the memory address, that is 1200. So otherwise it will move to the step number 5, add a byte of array sum. Again it will repeat once again. So this looping concept is running up to the end of the value. So this is why this is what we are discussing now. So this is the flow chart for the particular sum of an array. So these are all the instructions and conditions are played in this particular program. So here is the example for the sum of an array. So here we are taking input values here. So after the entering the programs in the microprocessor 8086 kit, and so we are after the execution, so we are giving the input separately. So 0 here is 06 as a counter, I mean count how many values are as taking as input. So we are taking 6, first value, that is 12, 47, C2, F5, 47, 56. These are the input values. So these input values are stored in the particular memory address, that is 1100 is 06 as taking as a count, and remaining will store in the continuously storing in the 1101, 02, 03 up to 1106. So after the execution, it will the added data is stored in the address, that is 1200. That is we are taking 16-bit values here, so it will stored in the 1200 and 1201. So here we got the answer for the particular input values, and that is 0 to AD. So AD will store in the address 1200 and 02 is stored in the 1201. So this is the calculations or example program for execution value, output value for the particular sum of an array. So thank you for watching this video. So we will continue this lecture series in our next video. Thank you.